going to explain internal organization of memory. In that, we will see how our memory, especially the RAM, random access memory, okay, that memory was designed internally. That means actually when we saw our RAM chip, see, we can see one small IC, right? So internally that memory, how it was designed, how it was structured, how it was constructed, the logic or the idea or the circuit of that RAM that we are going to discuss under this chapter, okay, or under this topic. Now, we know that flip-flop. One flip-flop is nothing but a memory cell which is used to store only one bit of information. See, already you people have studied what is flip-flop in another subject called digital design or logic design or digital electronics. In some universities it will call by different names. In that subject, in the digital electronics, you have studied a topic called flip-flop. A flip-flop is nothing but one switching element, also called as memory element, in which we can store only one bit of data. Either we can store 0 or we can store 1. That's it. That's what the flip-flop that we will use. Now let us see in one flip-flop. So we discussed in one of the bus structure video, there are 3 different types of buses: address bus, data bus, control bus. So bus means collection of wires. Okay, with one wire. Assume I'm having only one wire. What are the possible values I can pass? So in that only one wire, either I can pass 0 or I can pass 1. That means with one line or one wire, one line, I can pass either 0 or 1. That means with one input, I can have 2 possibilities. Only one wire or one input, 2 possibilities, either 0 or 1 I can pass. Similarly, if you say, suppose if I'm having 2 lines, what are the possibilities in both the lines? See, suppose I have 2 lines, 2 wires, in here 0, both are 0, 0 I can send, or I can send here 0 or here 1. Similarly, here 1 or 0, here 1, 1. So that means with the 2 inputs, I am having 4 combinations. Similarly, suppose if I have 3 wires, I can pass 0, 0, either 0 here, here 1, or here 0, here 1. So like that I may have. So suppose if I am having 3 lines, I am having 8 combinations. So this already you are familiar with that when it is a truth table. Okay, so these are the 3 lines. 8 combination, 2, 4, 6, 8 combination. Similarly, suppose if you are having 4 lines, so then I am having how many combinations? So exactly, so this is nothing but 2 to the power of 1, this is 2 to the power of 2, that is 4, 2 to the power of 3, that is 8 combination, 2 to the power of 4 is 16, so I will get this 16 combinations. So this already you are familiar this one. Okay, why we need this? Because our system understand only what? Binary. So if you count, see 2, 4, 6, 8, 10, 12, 14, 16. 16 combinations. Okay. Similarly, for 5 to the power of 5. In general, if I'm having n number of lines or n number of wires, so then you can have what? 2 to the power of n number of combinations will get. In general, if there is n number of lines, 2 to the power of n number of combinations. Now, I will design RAM, that is random access memory, by taking 4 address lines. Okay. So this address we are giving the form of what? Binary. This is already encoded because see, we human being, we know only what? Decimal numbers. Whenever we are dialing any number or typing any number, we are pressing or we are entering only the digits from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, only these digits. So these are the decimal number system what we know. But these decimal digits cannot be understood by our system. So what you have to do, these decimal digits, okay, decimal is to be converted into what? Binary. So that means this is my what? Binary is what? It is already converted. It is a coded format. That means suppose if I say this is say this is 12. This is the coded format for this decimal number 12. This is the coded format. Now what I will use? Now I will use such a 4-bit address will use, 4-bit address. So now for that, I am going to use one circuit called 4-bit address. This is because 4-bit address means now I am passing 1, 2, 3, 4-bit address. There are 4 lines, 4 lines. I will name this as A0, A1, A2, A3. When I'm having, we can name it whatever. Just I'm using naming convention. I use A0, A1, A2, A3. Okay. So 4 lines I'm giving. So in the 4 lines, so whenever whatever any one of these possibilities I can give, any one of these possibilities. When these possibilities are in the form of what? Coded. This is a binary code. Now that I should bring back to what? Original decimal. That means I need to already, this is in the coded format, that I need to decode it. So I have to use, this is a circuit called 4-bit address decoder. This decoder, encoder also is studied in your that subject. What is that? Digital electronics or digital design, logic design. In that subject already studied encoder, decoders. So such a decoder I am using because I am giving the input in the form of the binary. That should be converted back into what? Decimal. So coded information I will to convert into what? Decode. So for that I am using the decoder circuit. So since 4-bit because I am giving 4-bit input. So this is a 4-bit address decoder. So now since 4-bit address decoder I am getting, the possibility is what? How much possibility? 2 to the power of 4 is what? 16. So that means I will get, I may be what? 16 lines. Okay. So 1, 2, 3. So like that what I will get? Maximum I will get 16 lines. Okay, so I will name it. Okay, this I will name it as W0, W1, W2. Similarly, last one is what? 0 to what? 15. W15. So that means 0 to 15. See, this is the decimal equivalent 0. This is 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 0 to 15. This is the decimal. This is a decimal, this is binary. Now I have to convert this binary to what? Into decimal. So for that I use decoder. So totally this one. Now like this I will get, these are my lines. See, I am not writing completely, so I am writing dot. Okay, so totally I have here I have written what? 4 lines, but 2 to the power of 4, 16 lines I will get. The word 0, W0, W1, W2, like W15. See this 0, 1, 2, 3, 4 up to 15, these are the decoding. Okay, this is decimal number, this is binary number. Okay, now, so this each line we are calling is a word line. One word line. So, okay, each line will call as a what? Word line. Okay, so this is called what? Word line. What do you mean by word? We know that in many of the videos I told, word is nothing but a group of bytes. Now I will assume in one word I am storing only 1 byte. One word, 1 byte. Okay. So I decided, so okay, what is that? I decided in one word, 1 byte. 1 byte means how much? 8 bits. So 8-bit means I need to use what? 8 flip-flops, because in one flip-flop I can store only 1 bit. To store 1 byte means what? 8-bit. To store 8-bit I need 8 flip-flops. So for that I will use what? 8 flip-flops. I am writing 1, similarly here 2, similarly here 3. See, I am not writing all 8. You can write 8. So that's why I did it dot. Okay. So this each one is one flip-flop. Flip-flop. Similarly, on this word all line also I am having 8 flip-flops. This you write. Okay. Eight flip-flops. Okay. Each one is one flip-flop. Each one is one flip. Now, these flip-flops are connected to the word line. See, this is connected. This is connected. This is connected. Each flip-flop is connected to what? This word line. See, this horizontal is one word line. all these one word line contains 8 flip-flops, is 8 byte, 1 byte, 8 bits. Okay. So now these flip-flops again are connected to one more circuit called sense or write circuit. This is one circuit. Similarly, here I am having one more sense or write circuit. Similarly, here one more sense bar write circuit. Sense bar write circuit. Now, to this circuit, all flip-flops are connected to this sense circuit. So I will write, see, from here onwards, dot dot dot, okay. Connected. Okay, now this flip-flop is connected, this flip-flop is connected, this flip-flop is connected. See all this. See this flip-flop in both the sides is connected to what? This one sense or write circuit. Sense or write circuit. Similarly, these lines also. Similarly, these flip-flops are also connected. Okay, now, these sense or write circuit are responsible to decide whether we need to sense, that means the read, whether from these flip-flops, whether I have to take the data or to these flip-flops to give the data. That means read or write. Sense or write means whether to sense, read, or I have to write that. So that it will be decided by two signals. Again, I am giving one is read or write bar. Read or write bar. Okay. And one more is called chip select, called CS. I will tell you later this one. Okay. So now based on this read write bar signal is given to all the sense or write circuit. All these are internally connected. Okay, same to read and write circuits are given. These two signals are given to all these sense or write circuits. Okay, now see, either from these flip-flops, either I am taking the data or I am giving the data. So the two bidirectional. So I will write this one bidirectional. Okay, now here I will simply draw this line, extend. Okay. So now these are called, now this I will call big C, come from this one. So this is my, always will say this is my least significant bit, this is my most significant bit. So least significant bit, so I will say this is B0 and this is my B0 bar. That means in this line B0 value getting its complement and getting in this one. Okay, because every flip-flop is having two outputs. One is Q, another is Q bar. One is complemented and uncomplemented. So every flip-flop has two outputs. One is B0, another is B0 bar. Similarly, this is my B1, this is my B1 bar. Similarly, B0 over, B1 over, B2 next. Then what? B3, B4, last one is what? B7. Similarly, this is B7 bar. Okay, in this line I am getting the uncomplemented true value. Here I am getting the false value, that is the uncomplemented value. Now that should be this. Now here either I am taking or either giving. So I will call these bits as a D0 data, D1. Similarly, what? This is my D7. Now these I will call my data input output lines. That means these are the external input as output as. When it will act as an input, that means I am giving this input. Suppose, assume I want to read the data. Already some data is stored in this flip-flop. Some data is stored in the flip-flop. Now I will decide which words see. 1, 2, 3, like this. 16 words are there. 16 words are there. Now I can select only one word. How I can select? First, I will pass on some values. Suppose I pass values say 0, 0, 1, 0. If I pass 0010, what is that coded form? 0010 means 2. That means, see, my word line 2, this line will be selected. Now this line will be selected. Now only this word line will be selected now. So this line selected means power, that is plus VCC. 5 words is passed only on this line. When I selected this line, now to this line, which are the flip-flops connected? Only these 8 flip-flops are connected. See, all these remaining are not connected. Only these flip-flops are connected to this. So whatever the data is there, that data, it will keep it in, because it will sense. Because I should assume, have sent this value is equal to 1. That means I will read. So now after selecting that word, whatever the value stored in this 8 flip-flop, either 0 or 1, whatever, that will be passed. I will now get this one output. This is how to read operation will be done. Suppose, what is another operation we can do with the memory? We can do write operation. Write operation, suppose I want to store, already some data is there in this flip-flop. Assume the same address I have given, same this line will be, word line will be selected. Now assume whatever the data I want to give, that I will say 0, some 1, 1 I will give. So let's say 8-bit data, what I want to store in these 8 flip-flops I will give here. Now I will make this signal as 0, it indicates you are writing. Now this data will go and it will sit in this flip-flop because only these are selected. This is how read and write operation will be done, and the circuit inside the RAM chip is, this is the circuit. Now here totally how many words we are having? 16 words. Okay, so here we are having how many words? 16 words. So 16 words, and in each word how many flip-flops? In each word how many bits? So 8, like that, 16 into 8. That means 16 into 8 is equal to what? 16 8s are 128. This is the but totally I'm having 8 plus 8, 16, 16 plus 24, 32, like that, totally 128 flip-flops I'm having here. So 128 flip-flop means 128 bit. Now that means we have designed 128-bit RAM. That means this is the circuit. So in order to design 128-bit RAM, now to design this 128-bit, see 128-bit is nothing. Actually we are using what? 4 GB, 6 GB, 8 GB, 12 GB RAM we are using. Okay, 4 GB, 6, 8 GB, 10 GB, 12 GB RAM we are using. But I am talking in terms of 128, small memory, very small memory. Nothing, just to show the construction. Okay, now see, to make this 128-bit RAM in this fashion, now how many external connections? See, all these are internal connections. All these are internal connections. These are internal connections. Now, external connections, what? Externally means I have to give this 4 inputs. So, totally here 4 address lines, and then, so totally I am taking data input output lines from these 8 lines. So, 4 plus how much? 4 plus 8. 4 address lines plus 8 data lines. So, these are data lines, data bus, and plus, see these 2 control signals. Okay, one is read write, another one chip select, 2 control lines. Plus, for everything, in order to pass the power, we need to give power supplies. One is VCC and one is ground. You did in the lab, I think. Whenever you use a trainer kit, as soon as you place the IC in the IC slot, you have to make VCC and ground should be 1. Okay, for that 2 power supply. 2 powers. Totally how much? 4 plus 8, 12. 12 plus 2, 14, 16. That means to design 128-bit, I need 16 connections. 16 connections. Now, slightly I will increase this. Now, from 128-bit, now I will decide what to make 256-bit. 256-bit means how much? Now, again, I will decide only 8-bit is enough now. In one word line, 8-bit. So now how much we know? 256 means 128. Now how? 32 word lines into 8. That means 32 words. In like that, how I am in 16 word lines, like that I am in 32 one, W0, W1, W2, like that, W31, 32 words, in each word 8 bits, so 32 into 8 is equal to 256 bit RAM. So this is the organization of 32 cross 8 RAM. Now for this how many connections? Now how many, see 32 words means, see 16 words means 4 addresses, 16 combination means 4. So 32 combination means what? 2 to the power of 5 is equal to 32. So I need 5 address line for this. 5 5 address lines plus how many? So this is same 8 data lines only plus 2 control lines plus 2 power supply. So this is nothing but how much? 13 plus 17 connections. That means simply double one more connections. Similarly, go for little bit more data. So that is from 256 to 512 bit. 512 bit means what? Now 64 into 8. Simply divide. Suppose you want 512 bit. Divide by 8, you will get 64. 64 words, 8 in each word, 8 bits. So this is nothing but 64 bit, 64 cross 8 RAM. And for this you need 18 connections. 18 connections. Because 64 means what? 6. 6 plus 8, 14. 14 plus 2. Plus 2. So 18 connections. Similarly, suppose if I assume I want to make it 1024 bit RAM. 1024 bit RAM. 1024 bit RAM means what? 1K bit. 1K, that means 1 KB. Now I come to the KB. So how you use 1 KB, 1 MB, 1 GB. So now still is 1 KB. 1 KB means what? So now divide by 8 again. Divide by 8 means, so I will get 128. So 128 into 8 is equal to 1024. That means for 128 means, so how much? So I should get 7, right? 7 address lines plus again 8 plus 2 is common. So 12 plus 17, 19 connections I want. So in order to make what? 1 KB RAM, I need 19 connections. Now simply imagine in order to make what? Your 8 GB, how many connections? Okay, 8 GB connections. Like 8 GB connection means again, what I told divided by what? 8 GB. So assume in your mobile or in your system, you are using 8 GB RAM. Now you can decide how many external connections you need for this type of connections. So that means 8 GB divided by 8, that is 1 GB. 8 by 8 is 1. So that means 1 GB into 8. So 8 GB got. Okay, this is 8 by 8 bits is 1 byte. Okay, so 8 bytes, 8 GB. Okay, 8 gigabytes. Now 1 GB means you need 2 to the power of 30 is equal to 1 GB. That means you need 30 address line plus what? 8 data lines plus 2 control lines plus 2 power supply. Totally 30 plus 8, 38, 40, 42 external connections. That means from externally we need 42 connections. See, that much connections make our hardware size bigger. Hardware size bigger means what? Or finally our device becomes bulky. But we want to use what? Slim mobiles or slim laptops. Our hardware devices always we expect what? Slim. But it will make bulky. That means this type of organization we are using only in case of second up to second generation system. Okay. So now this is not the ideal one because if you are increasing the size, see 128 bit, 16 connections. 256 bit, 17 connections, 512 bit, 18 connections, so 1K, 19 connections. See, when come to this one, 19 to 42 connections like that. So that is huge. So it will making our size of the system is more. So to reduce that, we go for an alternative method. Okay. Hope you people understood this basic organization of the memory. Okay, this is what the structure or the circuit inside your RAM at the beginning. But now what type of, so now same. Now this you remember, for 1 kilobyte, how many connections? 19. This you remember. So now I will clean this and we will see alternative diagram or alternative structure for the same RAM. Okay, so for this 1 KB, 19 connections. Remember, now same now I will design 1 kilobit, but I will reduce the number of connections. Okay, that we will see. See, now I told for 1 kilobit, we need 19 connections. Here I divide by 8. I decided in one word I am storing 8 bit. In one word storing 8 bit. So 128 word. So into 8, 1024 bit. Now I will design the same 1K, but now I will decide instead of having 8 flip-flops in one word line, so I will decide only one flip-flop in one word line. Okay, in one word, I will decide only one flip-flop. Okay, so now one word in one divided by, see, 1024 divided by 1 means 1024 only. That means 1024 into 1. This is not 1k into 1. That means one data line. So 1k, 2 to the power of 10. 2 to the power of 10 is equal to 1k. Okay, so now I need 10 address line for this, plus only one data line, plus 2 control signal, plus 2 power supply. So totally how much? 10 plus 1, 11, plus 2, 13, plus 2, 15. That means only 15 connections. Now let us see, theoretically I shown that's it. So how we can reduce for 1 kilobit memory organization from 19 connections, we can bring it to 15 connections. I can reduce this much drastically. Okay, so that when we will discuss. Okay, now, so since I need 10 address line, this 10 address line, now I will divide it into 5, 5. 5, 5. Okay, the 5 I will make it as what? Address for the row address and column, because now still now what I did, so rows will be there and some columns will be there, 8 columns. 16 rows and 8 columns we are having, right? So now that instead of that, now I will make 5. That means 32 cross 32 I will make. Okay, 32 cross 32 I will make. That means, see, I am having 1, 2, 3 like that, 32 rows. Similarly, I am 32 columns. So now 32 rows into 32. 32 into 32 what? 1024 only. So now that logic I will use. Okay, so this logic I will use now. Now what I will use, 5-bit address decoder. How I use 4-bit address decoder there, similarly now I will use 5-bit address decoder. So 5-bit address decoder means you should get how many lines? So 1, 2, 3, 4, 5. 5 address lines. Now, these are the 5 bit. Out of 10 address lines, I use this 5 to select one of the row out of 32. So, since 5 bit, so 2 to the power of 5 is 32, I will get 32. Okay, 32. So, that means 1, 2, 3, like that I will get 32. So, I will call this as a word 0, word 1, word 2, like this last one is word 31. Word 0, word 1, word 2, like that, word 31. So totally 32 lines I got. Now, these things, now I will make it as 132 cross. Now, this is my memory. How I arrange the flip-flops? In the previous diagram, 8 flip-flops in 16 rows. 16 into 8, 16 into 8. Like that, now I will make 32 cross 32. That means 38 rows and 32 column memory cell array. That means I am arranging the flip-flops in the form of array. Okay, so 32 cross 32, 32 rows, 32 column. So to identify one row, 32 means 2 to the power of 5. I am using 5 address lines. So, okay, let us say this is A0, A1, A2, A3, A4. You can give any other name. Okay, not a problem. You can start from whatever. But simply I given these names. Now, when I give some value, based on this binary value, it will set any one row, any one word adversion. Now, since I have stored only one flip-flop in one word, right? So, out of 32 rows, it will set only one row. Now, I have 32 columns. 32 columns. Now, I need to set one column. So, for that, I am using now, these are my what? These are my sense or write circuit. Whatever in the previous I used. Sense or write circuit. That sense or write circuit. Okay? Sense or write circuit. These are connected here. Now, this is connected to my data output. Okay. So, now I am having my data input output. This is my what? See, third, I will say input de-multiplexer and output multiplexer. that is mux. Again, these are the two circuits. Again, you discussed in the same digital circuit or digital design subject. Now, multiplexer is one circuit, combinational circuit. So it is having many input lines. Out of many input lines, I need to select one. Okay. So many input line, many input. So I have to select one output line. One output line. For that I am using, so out of many options I have to select one. For that I am using what? Multiplexer, mux. Suppose I am having many outputs. Okay, that means one input, but I need to, out of many output lines are there. This one input line, I need to pass it any one of the output lines. So for that I am using demux. Now, see, this is my output. Okay, this is my input actually. Okay, 32 rows are there. 32 rows, now I need to select one. Okay, let me complete this diagram now. See, this is bidirectional. You can write in only one line also, or in like this also, not a problem. Okay, in only one line, only like this, write like this, or like this only, not a problem. Now here, see, here 5-bit input I have given. Out of 32 combination, I am selecting any one. 32 rows, I select one. Now I have 32 columns. Out of 32 columns, I need to select one. So to which one to select? For that, again, I am passing here. So 5 lines. 1, 2, 3, 4, 5. So this I will continue. This is A5, A6, A7, A8, A9. Totally what? 10. So that's all the 10 address line. Now, so these lines I use to select one row. So I will say these are 5-bit row address. And these lines I use to select what? One column. So I will say 5-bit column address. 5, this is used for to select one row, this is to select one column. Now assume I select some 10 bits. So this will select any one row and this will select one column. Now whatever that column I will get, so that I will get from this data input output line. This is my what? Data input output line. That is what? One data line, only one data line. Earlier I used to 8 data line. Now I am using only one data line. So now, see, each sensor write circuit, again it contains what? Two signal. One is read write bar, another one is chip select. Okay, this is given to all the sensor write circuits. Okay, now this sensor read circuit decide which read or write. Now chip select, it's called chip select. CS means chip select, because sometimes we extend our RAM in our system, right? Suppose our RAM is full, so now we'll add one more extra secondary RAM we will add. We can extend our RAM. Okay, so that means assume right now in my system 2 GB RAM is there. Next I can add one more RAM slot. Okay, so that means when I have two chips, to which RAM I need to do this operation, read or write operation. For that, we are using this chip set. That means when we are having multiple RAM chip in our motherboard, to select which one, we are using this chip set. Okay, so this is how the another alternative. So if you do in this alternative arrangement, so we can get, instead of 19 connections, we'll get what? Only 15 connections. See, 10 plus 11, 13, 15. 15 connections only. Now, what is we mean by this input? Okay, input demultiplexer and output multiplexer. Input demultiplexer is, see, 1:32, and whereas output one is what? 32:1. So what is that? See, when I given this, 32 inputs are there. Out of 32, I have to select one. That is 32:1 output. That means I have to select that 32:1. That is what output multiplexer. So when I want to give input data, I am having 32 options. I have to select one. That I have to pass it in any one. So 1:32 demultiplexer. Okay. So and when you are performing read operation, you are here in this circuit demultiplexer will act, and when you are selecting for read operation, so multiplexer will act. Okay. This is the alternative arrangement. So that means this is the arrangement of the RAM structure we are using in nowadays technology. Okay, so this is how our RAM or memory is organized internally. Hope you people understood. If you have any questions, please write it in the comments. Thank you. Thanks for watching.